Hi everyone, I am Ashutosh. In this video, I'll talk about time series and fixed size chunking strategy. I will apply these two chunking strategies on real-time stock data, and I will also do the performance comparison. I will give you this demo in two parts. So part one will be I will fetch the data for Tesla for 1 month and I'll break it into chunks. I will do the performance comparison on these parameters reflecting on the screen, and then in part 2 a user will give a time range as an input, and for that a specific time range we are going to do the chunking and we are going to do the performance comparison. So let's go to the utility and see how it works. Let me run this program first and see the output, and after that I'll explain you what has happened behind the scene. So you will see that just in few seconds, maybe in 1 or 2 seconds we have got the output, and it clearly reflects the execution time both for time series and fixed size chunking that we have done on the data that we have fetched from the Yahoo Finance. And memory usage here is not reflecting because you can see in the console that memory usage is almost 0 MB. That's the reason it's not reflecting here. Now let's go to the property file and see. For fixed size chunking here, chunk size we have decided as 100. That means that 100 rows will be part of chunk 1, each chunk you can say. And we have fetched the data for from Yahoo Finance for Tesla for this period, December 29th to January 17th, almost 3 to 4 weeks of data, and we are going to store it into this file, Tesla time series demo.csv. So you can see that on left hand side this file has been created. Now let me open this file and let's see how many rows it has. So it has around 4681 rows. Now as part of fixed size chunking, when we have defined chunk sizes 100, means you can imagine how many chunks will be generated. So 4681 divided by 100, almost 46 to 47 chunks it should create, and it will create in the path. You can see here process data folder is data processed time series. So in this folder I am storing it. So data processed time series, you can see here. So now you have fixed size as well as time series, both the chunks. Using both the strategies I have created the chunks and it is reflecting here. So let's evaluate fixed size chunks here. So you can see here that 47 chunks have been created. So almost every chunk has 100 rows, and the 47th one will be slightly less than 100. Now let's do this one more time. Let's run this program one more time, and this time I'm going to put chunk size as 1000. So now we know that 4600 odd rows were there, and chunk size is 1000. So it should create almost 4 to 5 fixed size chunks. So let me save it and let me run this program. So almost 5 chunks it should create. So okay, you can see the output here. Now you can see fixed size chunks 5 it has created. So now you can see here that the property file that where we have defined chunk size as 1000 or 100, or you can change it to any number of chunk size. Accordingly, it will take the entire set of data, it will break it into equal part depending on the chunk size, and it will create the fixed size chunks. So this is how the fixed size chunking is done, and you can see the output also, where it shows the execution time and number of chunks that has been created. Okay, so let us see what has happened in case of time series. So you can see here that interval is 1 minute. That means when we have consumed the data from Yahoo Finance, it has data for every single minute, and that's what you can see here in this property file. I'm sorry, that's what you can see here in this CSV file. You can see the timing as 14:30, 14:31, 14:32. So you can see here that for every single minute we have got consumed the data, and that is nothing but as per this interval. Now for time series chunking, here we have defined that chunk interval will be chunk interval is 10 minutes. That means every chunk will have 10 minutes of data, and every row has, let's say, 1 minute of data. That means every chunk will have almost 10 rows. So let us see one chunk from time series, and you can see here row number 4 to 13, so almost 10 rows are here. So basically 10 minutes of data is there in the time series chunk, and number of chunks you can see here, it's pretty high. Yeah, it's pretty high, 468, because we have divided 4680 odd number of rows by 10. Why? Because every chunk has 10 minutes of data, so 10 rows. So that's the reason it has 468 number of chunks. So let's do one thing. Let's quickly update this property file. So let's say in case of 10 minutes, this chunk interval, let's change it to 50, and let's run this program one more time, and let's see what happens. Okay, so you can see that the chunks have been created. Execution time is reflecting here. Memory is again 0. And let's go to the number of chunks that is updated here quickly. Fixed size is still 5 because we are still 1000. But here time series, let us see, 103. So I mean that is expected because we have changed the chunk interval to 50 minutes. So let's say, let's change it to, let's do it one more time. Let's run it one more time, and this time I'm going to change it to let's say 25, and ideally I should have double the number of time series chunks in this case. Let's run it one more time quickly and see the chunks that is generated here. Okay, so the program has run. This is the old output, and you can see that the number of time series chunks is 196, almost double. So basically this is what is expected, and so this is how you can see that this is the property file using which I'm controlling the number of chunks. So every time I'm getting the data, which is raw data, which is there in this Tesla time series demo.csv, where I have consumed the data for 3 weeks or 1 month, and I'm defining the chunk size for fixed size chunking here, and also I'm defining the chunk interval and chunk interval here for time series chunking, and based on that, when I run the program, the chunking happens. So now you can clearly see that how fast we can break the data, we can make chunks, and we can come up with the execution time and memory usage and all whatever it has consumed. Okay, so this was part 1, and now we will go to the part 2 of this demo. And in this case, what we are going to do is that we are going to user will give a time range as input, and based on that time range the chunks will be created, both in case of fixed size as well as this time series, and we will do the comparison. So let's quickly, so let me go to the second program. So here this is the program, and this is the property file. So in this property file, let me make it 1000 as chunk size, and for time series, so this 1000 is for fixed size chunking, and for time series we have 5 minutes chunk interval. Let me make it 20 minutes of chunk interval. Let me run this program, and in this case what we are expecting is that it will ask for a time range as an input, and when we provide the time range, then it will create the chunks in both the types, time series as well as fixed size, and it will do the performance comparison. And I have already kept these time range ready, and all these have a different purpose. For example, this is for multi so in case of multiple days, you can see here 12/27 to 12/29, so more than one day we have. And similarly, if we want to look into a specific days trades, then this is for full trading day. So just for Jan 5th, you have starting 9:30 to 4 o'clock. And let's say if you want to go if you want to deep dive just for a very small time range, so for example, so you can see here that this window is a specific time window is just on Jan 10th, we have 10 o'clock to 11:30, so just 1.5 hours of time range. And similarly for morning session 9:30 to 12. So basically we have a different type of time range. You can go for more than a day to just few hours also, and based on the time range that user gives the input, we do the chunking, and using both the time series and fixed size, and we can get the performance. So in the real world scenario, it depends like how much data you are consuming, and do you want to deep dive on multiple days, or do you want to deep dive for a very short period of time. So for example, Tesla the stock has, if you have seen a spike in half an hour range, so in that case maybe you want to do the chunking just for that half an hour range, and you want to deep dive and see what has exactly happened. So maybe that we will see in the upcoming videos, but for this demo sake, let's see what is happening here. So let me run this program first and then give these time range as input and see how it works. Okay, so now I'm expecting this program to ask me, yeah, so time range as an input it is asking. So let me give this time range, which is for multiple days, and you can see here we have got all the comparison. And yeah, in this case memory usage is also reflecting, which was not reflecting earlier. So yeah, we have the stat for all execution time, memory usage, and number of chunks it has searched. One more thing, you can clearly see that in case of time series, it is searching, and the number of chunks that it has searched is more, and that is nothing but due to the time interval that we have selected in the property file. So let us run this program for a different time range and see. And this is for a full day trading. So for one specific day, one full day, which is Jan 5th, I'm running this. So yeah, so basically it has gone through all the data which is for this specific day. The chunk has been created in both the ways, for fixed size and time series, and this is the stat for that. Similarly, we can run this for a specific window, and of course you will get the result. Yeah, so you can see the execution time, number of chunks. In this case, hardly the memory is not consumed, that's why it is not reflecting here. And you can see here on the console also, here also we are reflecting that how much is the execution time or memory consumed, or chunk number of chunks searched. So yeah, so that's what it is. So let's recap what we have done here. So we have applied, we consumed the data from Yahoo Finance, and then we did the chunking both for time series as well as fixed size, and for these two chunking we have done the performance comparison. In first case we are just chunking the entire set of data, and in second case user is giving a specific input, and based on that this chunking is happening, and we have done a performance comparison. Now let's think about a bigger picture, what we had talked about in the last two videos. So in the very first video we had talked about the overall RAG workflow. So you can see here that in the very first video I had talked about this Retrieval-Augmented Generation RAG, all the steps and how we had applied it on the real-time stock data. It included all the steps like, okay, fetching the data, chunking, we did the embedding, we stored into a vector store, and then user, we got a query from the user, again we changed it into vector, and then using that we did a similarity search in face, and then we got a response, we created a context, we took that along with the user query and we went to the LLMs and we generated the response, and basically the Q&A, question and answer, was happening on the stock data. So in the very first video we had talked about this RAG workflow and how we applied it on the stock data, every single step. The second step here was chunking, and that's what basically chunking is very important in the RAG workflow from the overall performance perspective. So that's why in the second video we had we did the deep dive in fixed size chunking, and yeah, this was the third video, and here we talked about time series chunking strategy, and I also wanted to compare it with the fixed size, and that's the reason I did not talk only about the time series chunking strategy in this third video. I did a comparison with fixed size chunking also. So basically, depending on the performance, we can take a call which chunking strategy we should go ahead with. Yeah, so I think with that I'll wrap up this video. So that's all from my end. Yeah, let me know whether you liked it or not. Thank you.